Okay, this presentation will look at the nitrogen cycle. And we know the nitrogen cycle already. We start with atmospheric nitrogen, which can be converted into ammonium compounds through nitrogen-fixing bacteria in root nodules or nitrogen-fixing bacteria in the soil. Ammonium compounds and ammonia in the soil can be converted into nitrates by nitrification. So the bacteria which cause this process to occur are nitrifying bacteria. Nitrate in the soil can be converted back into nitrogen by denitrifying bacteria. At the same time, nitrogen compounds in plants can be broken down through ammonification to produce ammonium compounds and ammonia again. And these are decomposers, bacteria, fungi, etc. Urine from animals, dead animals, and so on can also cause this to occur. So the nitrates are taken up by assimilation into the nitrogen compounds in the plants, and animals will get it through consumption. And notice in this graph we have blue lines for natural activities and red lines for human activities. But the nitrogen cycle is something you already know. So what we're going to do is describe how the nitrogen cycle within an ecosystem and the role of microorganisms. The role of the microorganisms are as decomposers and as nitrification. All of these processes are important. And then explain how energy flow and nutrient cycling are important for ecosystems to remain self-sustaining units, and for the distinction between energy flow and nutrient recycling of an ecosystem. So another generalized description of a biogeochemical cycle is here, where we have an atmospheric component, where we have gases, particulates, and vapors, which can be carried into soils as insoluble minerals in atmospheric deposition. And this process can go in the opposite direction. And of course, biological processes can also absorb atmospheric nitrogen. So absorption and deposition and biological processes. Biological uptake is here. This arrow, we're giving living autotrophs and biotrophs. So through photosynthesis and nitrogen fixation and so on. You have absorption of gases can be made into chemicals. So we have this system here. And we need to compare energy flow and matter recycling. So energy flow refers to the transmission of energy from one trophic level to the next in food chains. And notice the point is that energy degrades. It gets turned into heat and is therefore no longer available to humans. Whereas the matter is the same. So the matter will recycle, but the energy can't. And what happens? 10% of the energy is transmitted to the next trophic level, while 90% is wasted. That energy is degraded, whereas matter moves from one place to another, but it's not wasted. and the movement from primary producers to secondary consumers and tertiary consumers. And whereas the movement of matter through decomposes plants, animals, water, air. The point is in matter, it's recycled, whereas in energy, it isn't. The key thing is energy degrades. But the nitrogen cycle is simple and straightforward. It is something we've looked at. Well, we've looked at it from CSIC. We just need to study this cycle and know the different processes: ammonification, nitrification, denitrification, nitrogen fixation. And some nitrogen fixation is through the Haber process. So therefore, a lot of energy is lost this way, because converting atmospheric nitrogen into ammonia requires a lot of energy. Although most ammonia is made to make fertilizers with. That's it.